Welcome to Diksha Vedantu. I'm your physics teacher Aditi, and today I have come up with a very important video, top 10 CBQs. We have top 10 case-based question. Let us understand first what exactly a case-based question is, right? So a case-based question, actually, my friend, is they'll give you a kind of a story. Okay, and when you read that story, just like English, you have unseen passages. Here you will also have a kind of a passage. From that passage they'll ask you a question, but the questions will be from your syllabus, from science, what exactly they are asking. Okay, now each section, earlier it used to be 3 questions in the total science paper, one from physics, chemistry and bio. Now everything is same, just that they will be divided into only 3 sections. We know that our paper will be divided into 3 sections. Now earlier there used to be a different section, section number E, where you had case-based questions. Now in section A you will be having chemistry, and at the end you will have one case-based question of chemistry. Similarly for bio, and similarly same for physics. Done. Now they'll give you a passage first, right? And after that passage they'll ask you almost 4 questions or 4 MCQs. It can be MCQs, but don't just rely on MCQs. It can be a reasoning question, and then it can be a numerical as well. Although it won't be that tough, it won't be a tough numerical, it will be a simple numerical, but it can be a numerical. In total, we know till now it will be of 4 marks. Okay, for each bio, physics, chemistry, there will be 3 case-based questions, each in their own sections. Each will be of 4 marks. Done. Now for physics, we have 2 very important chapters. The chapters are light. First, the chapter is light, and second is electricity. From these 2 chapters, the chances of getting your CBQ is very high, and from this light chapter it is very high, almost 80 to 90%. Okay, and from electricity also the chances are high. On the other 2 chapters the chances are not that much high, but we are not taking any risk, right? So in this video we'll be doing CBQs from all the chapters. Okay, all the 4 chapters: light, electricity, magnetic effects of electric current, human eye. Done. Let us start with the first question. Before that, how to solve the CBQ. Okay, how to solve actually the CBQ, right? Now, ma'am, I'll have a passage, I'll read it, and from that I'll answer. Yes, you can definitely do that. But imagine you don't have time to read that passage. What will you do? We'll jump directly to questions. Jump to questions. Why? Because in English you have to read the passage. It's an unseen passage. You have to read the story first and then answer. But in science, it will come from your syllabus. You have already studied everything that is there in the syllabus. From the syllabus, they'll ask you the questions. So you don't really have to study the passage. We'll look into the questions first. Then if we think like, okay, this question needs some reading, we'll go back to it. But first we'll look at the questions. Okay, let's see if it works or not, if this trick works or not. Okay, the first question, Ravi and his father. We are not reading the paragraph first, we are jumping to questions. If we don't find anything in the question, we'll go back to the paragraph again. Okay, name the 2 mirrors used in this laughing house. Now you have to read the passage. This is what I'm saying. See, where you can answer, I'll get you the questions where you don't have to even read the passage, but in this we have to. So what are they saying? Ravi and his father went to a fair in a city. In the fair, when they entered in the laughing house, he experienced different image formation by different shapes of mirrors. We have done these kind of questions, very easy. In a mirror, he observed that the upper body was looking fat and the lower body was looking thin. Upper body was looking fat and the lower body was looking thin. This is somewhat our Ravi looks like. Okay, so we have to name the 2 mirrors used in the laughing house. Ma'am, this is very easy. We know that the upper mirror will be there will be two mirrors. The upper will be concave, right? Because it forms larger images. Convex mirror never forms larger images, right? So the lower one will be convex mirror. Right? Now the next, name the mirror in which size of image looks small or diminished. In which mirror? See, this question you can do without reading. Which mirror always forms diminished or small images? That will be my convex mirror. Very easy, right? Mirror. Okay? Now, see, because they have not mentioned that it is a real inverted image, that means they are saying it's a virtual erect because it's a laughing house. If you see an inverted image, they'll tell you that it's a laughing house and the Ravi is seeing an inverted image. Then it will be concave mirror. But if they have not mentioned that this is an inverted image, that means it's a convex mirror. Done? Cleared the confusion? Then how plane mirrors used at home are different in the characteristics. They are asking how the plane mirror is different than spherical mirror. Ma'am, this is very basic, we know that, right? Plane mirror does not form fat or thin or large or diminished images. It forms this image that is of same as the size of object. The size of image is equal to the size of object, right? And the thickness and thickness and thinness both are also equal, right? And size is equal, thickness, thinness both are equal, and it will be of same distance from the mirror as the object is, right? Done? Okay. Next CBQ, we have the ability of a medium to refract light. What did I tell you? Before reading this major passage, jump directly to question. Now, determine the speed of light in diamond. If the refractive index of diamond with respect to vacuum is 2.42, speed of light in vacuum is C. This is what I'm talking about. For this particular numerical, this is a normal general numerical. You don't even have to read the passage, right? So let's solve it directly. We have to determine the speed of light in diamond, right? We need to determine the speed of light in diamond. What is given to us? If the refractive index of diamond with respect to vacuum is 2.42, diamond with respect to vacuum is 2.42, and velocity of light in vacuum is given as 3 into 10 raised to power 8 meters per second, right? You can definitely find this. We'll see quickly, right? I have told you so many times how to solve these questions. Okay, so in this we won't focus majorly on calculation, we'll focus majorly on how to solve the CBQs. Done? Okay, still I'll tell you, see, this will be ND divided by NV, right? That means velocity is inversely proportional to refractive index. So velocity in vacuum divided by velocity of light in diamond, right? So this is given as 2.42, and velocity of light in vacuum is 3 into 10 raised to power 8 divided by velocity of light in diamond. So velocity of light in diamond will be 3 into 10 raised to power 8 divided by 2.42. Right? Now, if you don't have much time in the exam, see, 2.42 is normally basically equal to 300, right? Is equal to 3. Okay, so you can cut this and write something like 1.12 or 3, but you have to write approximation. This is a secret trick, don't tell anyone. Okay, this is meter per second. Or if you don't want to write 1.2, you can directly write that velocity of diamond is approximately equal to 10 raised to power 8 meters per second. Done? And now, if you don't have time, only then use this trick. Otherwise, you have to do the calculation properly. Done? You have to do the calculation properly. It will be something around 1 point something. Okay, not much, but you have to do the calculation properly. Done? Okay, let's move on. Next we have a question when, oh, we had lots of questions. Sorry, my mistake. Okay, first part is done. Second, refractive indices of glass, water and carbon disulfide are this. So we are 1.5, 1.33 and 1.62. Let's just write. One is 1.5, second is 1.33 and the third is carbon disulfide, and that is 1.62. This was glass and water. This was glass and this is water. Done. Right? Now what they are asking us, if a ray of light is incident on these media at the same angle theta, their angle is same, then write the increasing order of the angle of refraction in this media. See, again, you don't have to read the passage for this particular question as well. What you have to do, you just have to see, you have to technically you have to tell where the theta will be maximum if light goes from air into these medias. Right? Now, of course, we know theta will be maximum for maximum refractive index. Right? Now, whose refractive index is maximum? That is carbon disulfide. So, theta of carbon disulfide will be more than theta of, now glass is next, then theta of glass, and that will be more than theta of water. Very basic. Done with this? Very basic. You tell me if you have any doubt. Until now, any doubt? Okay, now the next, this is also done. The next is the speed of light in glass is given as this, in water as given as this. Which one of the two is optically denser and why? See, third point says that we are given, I'll just give you a hint, okay? We are given two refractive indexes, 1 and 2. Let's say they are given as 2 and 3. Right? I'm just taking an example. It's very easy. Just listen to me. Now, they are asked whose optical density will be more. Whose optical density will be more. Right? Wait, I think we are given with speed of light. Okay. So, speed of light in glass and speed of light in water. It is 2 and 2.25. 2 and in water it is 2.25, right? Okay, now whose speed of light is more? In which medium speed of light is more? Speed of light is more in water, right? Speed of light is more in water. So optical density is inversely proportional to speed of light. So whose optical density will be more? Optical density of glass will be more than optical density of water. Whosever optical density is more, light will travel with less speed in that medium. Light will travel in less speed in the medium, with less speed in a medium whose optical density is more. Right? More the optical density, less the speed of light. Done? Understood? Okay. Next we have option B. It says a ray of light is incident normally at water glass interface when it enters a thick glass container filled with water. What will happen to the path of ray after entering the water? Ma'am, this is very basic. A ray is entering from air into water. Right? Now, if it is entering from air into water, let's just read it again very carefully. A ray of light is incident normally at the water glass interface. Okay. When it enters a thick glass container filled with water, what will happen to the path of ray of light? Now, see very carefully. This is not... See, we have a glass of water, right? So this area is glass, right? So, and this area is water. So here ray is going from air into the glass, right? Ray is going from air into glass. See carefully. First ray is going from air into glass, right? Then the ray is going from glass into water, right? Now glass is denser, water is rarer. So when ray goes from denser to rarer, you tell me, when ray goes from denser to rarer, where did it bend? Where will it bend? So where will it go? While the ray is going from denser to rarer, it bends away from the normal. It bends away from the normal, right? Clear? So we are done with the second question. Very easy. You just have to read it very carefully. Then, okay, next we have another question. See, again, without reading the passage, let's just jump into the question. Define the term absolute refractive index of a medium. Ma'am, it is very easy. The refractive index of a medium with respect to vacuum is called the absolute refractive index of medium. You don't have to go into the question, right? Even if you want to know the exact definition. The ability of a medium to refract light is expressed in terms of, oh, this is optical density. So I can just go through the paragraph if you don't know the exact definition. Although the exact definition is very simple, refractive index of a medium, or the ability of a medium to bend the light towards or away from the normal with respect to vacuum is called absolute refractive index of that medium. Then, okay. Refractive indices of glass, water and carbon disulfide. It's the same question. Literally the same question has been repeated. So see, you don't have to go into the passage. They have asked in which of these media is the speed of light will be highest. So speed of light will be highest in a medium which has lowest refractive index. Which has lowest refractive index? 1.33. 1.33 is of water. Done. And in which it's lowest, so speed of light is lowest in a medium which has highest refractive index. Highest refractive index is 1.62, that is of carbon disulfide. Very easy, very easy. See, these CBQs are almost free marks for you guys. Of course, if you are a topper, if you are a medium, if you are not studying well, all three kinds of students can benefit from this. If you haven't studied, go study this. These are almost free marks, 4 marks for free, and 4 in each section, that is 12 marks for free. Okay, and if you are a topper, if you are studying from the whole year, it shouldn't bother you at all. If you are an average student, go revise it a little bit and you will be okay with it. Okay, now the third is the absolute refractive indices of glass and water are 3/2 and 4/3. Let's write it down. The refractive index of glass and water are what? Write it very carefully. Okay? 3/2 and 4/3. This is 3/2 and this is 4/3. Right? If the speed of light in water is 2.25 10 raised to power 8 meter per second, find the speed of light A in vacuum, B in glass. If the speed of light in water is 2.25, speed of light in water is 2.25 into 10 raised to power 8 meter per second. We have to find the speed of light in vacuum and we have to find then speed of light in glass. Can you do that easily? Can you do that easily? I know refractive index, absolute refractive index of glass is with respect to vacuum. So this is N of G divided by N of V, right? That is refractive index of vacuum. So this is inversely proportional to velocity of light in that medium. So velocity of speed of light in vacuum divided by speed of light in glass. Now in glass we are not given. We have to find with respect to water is given. Okay, so instead of glass, take water. Very simple. Instead of glass, take water. In here as well, instead of glass, take water, vacuum, and here also water. So speed of light in water is given. That is 2.25 into 10 raised to power 8. This we have to find, right? Now, this is also given. Refractive index of water with respect to vacuum is its absolute refractive index. That is it, right? So this is 4/3. Now can you solve it or not? You have to, this is an easy calculation, divide by 3 into 10 raised to power 8. Let me know the answers in the comment section. This is slide number 13, my friend. Okay, let me know the answer of 13th slide in the comments. Answer in comments. I am writing for other students as well. Okay, so solve it and write it in the comments so all of the other students can also see the answer. Okay, similarly you have to see, find the speed of light in glass. Now in glass you have to see, so see this carefully. Refractive index of glass with respect to refractive index of water you can find, right? It is given refractive index of glass is 3/2, of water is 4/3, equals to 3/2 divided by 4/3, right? Now velocity of light in glass will be inverse of this, right? See, this is velocity of light in water, velocity of light in glass. This makes sense. This makes a sense. So if I just cancel this term out, this will be velocity of water divided by velocity of glass, that will be 3/2 divided by 4/3, right? Now velocity of water is given 2.25 into 10 raised to power 8 divided by velocity of glass. If you solve this, it will be 3, this goes up, 3 into 3 and 4 into 2, that will be 9/8. So velocity of glass will be what? If you just cross multiply this, this will be 2.25 into 10 raised to power 8 into 8 equals to velocity of light in glass into 9, right? Now you can just take this 9 into divide. Velocity of glass equals to 2.25 into 10 raised to power 8 into 8 divided by 9. Now can you solve it or not? I solved the whole question, only calculation is left. Answer in the comments. Answer in the comments. I'll see each and every one of your answers. This is slide number 14th. So write down in the comments 13, answer this. 13 velocity of vacuum equals to this. 14 slide velocity of glass equals to this. Done? Okay, let's move on to the next question. We have another question. Let's just jump into the question. Now, although this paragraph is really small, so you can read it as well if you want. Rohan, student of class 10, studied an electric bulb consists of a filament made of a metal having high melting point such as tungsten. Okay? We have to answer following questions. Name the gas filled in the bulbs to prolong the life of the filament. Again, ma'am, this is very easy question. Even nothing is there in the passage, but we know that it is mainly argon, right? Because it is an inert gas. Any other inert gas you can also write. Done. Next we have a current of 5 ampere is drawn by the filament. Okay, ma'am, current is given as 5 ampere. It is drawn of by the filament of an electric bulb. Find the number of electrons. You have to find the number of electrons passing through it in 30 seconds. In 30 seconds. How will you do it? Tell me, how will you do it? Very easy, don't worry. First, ma'am, to find number of electrons, I should know Q, right? I should know the charge, actual charge, then only can find the number of electrons, right? So for that, I can use directly Q equals to IT, right? So I is given as 5 ampere, T was 30 seconds, 5 ampere, 30 seconds. So I'll just multiply this and Q will be 600 seconds. Q will be 150 seconds, right? Now I can easily solve number of electrons. Ma'am, N into charge on one electron is equal to total charge. Total charge is 150. Oops, my mistake. This is Coulomb. This is Coulomb, and number of electrons we have to find. Charge on one electron is 1.6 10 raised to power minus 19, right? So number of electrons will be 150 divided by 1.6 into 10 raised to power minus 19. Let me know in the comment section how many electrons are there in that charge. in this charge, how many electrons are there? Again, the slide number is 16th. Why am I giving you so many calculations? Because first, this is a CBQ video, so we are only trying to see how to solve the case based question. Second, I want you to practice calculation rightly, straightforward. Many students I know, they leave the question till here in the practice, in the revision. This is where you lag. This is where it makes the difference between you, between the topper who will get his photo on the board of the school, and between you, my friend. This is the only difference. Solve it till the end, solve it and let me know the answer in the chat. This is slide number 16. Slide number 16, number of electrons equal to this. Okay? Okay. Next question we have, okay, directly jumping to questions. Which law is based on the heating effect of electric current? For this, do you need to read the passage? No, you don't. So for first, we know the law. It is Joule's law of heating, right? Joule's law of heating. Correct. Done. And write its mathematical expression. Very easy. Mathematical expression is H equals to I square R into T, or V square into T divided by R. Done. Easy. Second, he observed that the cord of an electric toaster does not become hot, but the heating element of the toaster does. Why? Arey ma'am, this is very easy. The cord is made up of the cord is made up of copper wire and it is insulated, right? And copper wire has very less resistivity, right? It has very less resistivity, and because it has very less resistivity, that means, see, H equals to I square RT. If it has less resistivity, it will have less resistance as well, and if resistance is less, heating will also be less, right? Heating will also be less. Easy. Understood? That's how you have to write in the exam. Done. Next, the rod. What they have asked, the heating element. For heating element, we use alloys, right? We use alloys. Heating element. For heating element, ma'am, we use alloys. Now, resistivity of these alloys is very high. That means resistance is very high, and H equals to I square R into T. If resistance is high, heating will be also high. Done? Done? Okay. Next part, we have state one difference between the wire used in heater and in fuse wire. We have two wires, that is first in heater and second in fuse. First of all, tell me, what do we need in heater? We need heater to get heated, and we need fuse to not get heated much. We need fuse of less resistance. We need fuse of less resistivity. The wire of the fuse should be of less resistivity, and the wire of heater should be of more resistivity. Why? Because we need heating here, right? We need heating here, but here we don't need heating. We need melting. Whenever a greater current comes, we need the fuse to melt. But in heater, whenever the current comes, we need it to get heated. For it to get heated, it should have more heating. That means it should have more resistance. That means it should have more resistivity. Okay. So the wire of heater should have more resistivity. The wire of fuse should have less resistivity. It should melt when excessive current passes through it. It should not melt. It should get heated when excessive current or normal current passes through it. Okay. Okay. Next we have from the chapter magnetic effects of electric current. A magnet produces magnetic field lines around it. Okay, we are not reading it, let's jumping into the question. Draw magnetic field lines of a bar magnet. Do you need to read the passage for it? Very basic. Draw a bar magnet, draw north pole, draw south pole, draw the magnetic field lines. We know outside it goes from north to south, inside it goes from south to north. Done. Okay, similarly you can draw in below direction as well. Just make sure they are not touching each other at all. Okay, this is the first. Then give any two properties of magnetic field lines. First, they are closed loops. Second, they do not intersect each other. And third, if magnetic field lines are much in density at one point, that means the strength of magnetic field is high. If they are not much denser, that means the magnetic field strength in that region is low, right? Three properties. Okay, then if a bar magnet is cut from the center into two equal halves, describe the polarity of two halves. We know, ma'am, don't try to trick us. CBSE tries to trick us always. We know even if we cut the magnet, both halves will have similar north poles and south poles. Done. Basic. Very good. Okay. Their polarity, they will not be of a single polarity. Both will have both north poles and south poles in them. Okay. Okay. Next we have, oh, big question, but we are not reading the passage, we are jumping directly onto the questions. There are just two very basic MCQs. A magnetic needle is or an isolated north pole pivoted at its center of mass, an isolated south pole pivoted at its center of mass, ordinary needle made of soft iron and pivoted at its center of mass, small bar magnet pivoted at its center of mass. You have to tell me the answer of this question in the comment section. I will not tell you. This is very basic. This is slide number 24. Answers in the comment. Answers in the comment. By my, wait for it, by my, oh, wait for it, by my lovely kids. Okay, answer in the comment. Okay, this is a heart. Okay, next we have a freely suspended magnet always rests in geographically north and south direction because the earth has two poles. The earth behaves as a huge magnet. The magnetic north pole of the earth's magnet is located very close to south pole. The magnetic south pole of the earth's magnet is located very close to the south pole. Which is the true answers? See, the magnetic north, this is my earth, and let's say it is aligned like this. So this is the south pole and this is the north pole, but these are magnetic souths and magnetic norths, right? In the direction where my needle points, where the north of my needle points, see, if this is the direction of compass, right? So this is north and this is south. So north actually points to geographical south. This is magnetic north of earth, magnetic north of earth, but actually it is geographical south. Right? So which one is correct? The magnetic north pole of the earth's magnet is located very close to south pole. Can be correct. The magnetic south pole of the earth's magnet is located very close to its south pole. That is not true. So the correct option is answer number C. Okay, let's move on. Name the possible defect he is suffering from. Who is suffering from? Go back to the passage. Okay. On one of the Sunday morning, Neeraj was reading a newspaper. He was facing difficulty reading a text of one of the advertisements. His sister suggested him get his eyes checked at eye care camp. So now he is reading a newspaper. So of course he won't be standing here and placing the newspaper far away. Newspaper will be somewhere here. That means he cannot see nearby objects clearly. He can't see can't see nearby objects clearly. If we cannot see nearby objects clearly, which defect is that? That is, ma'am, that is hypermetropia. Hypermetropia. Done? Everyone? Understood? Then this is done. Write two causes of this defect. What are the causes of this defect? Ma'am, hypermetropia is caused when the image is formed behind the retina. Behind the retina. Oh, let me change this spooky color. Right, when the image is formed behind the retina. Now if the image is formed behind the retina, it is because of two, that the size of eyeball got shortened, right, or the focal length of my lens, focal length of eye lens becomes large. Done. These are the two causes. Okay. Next we have write two causes of this defect. Done. Draw the ray diagram showing the correction of this defect. Now first, ma'am, to correct hypermetropia, which kind of lens we use? We use convex lens. Now let us draw its correction. First I'll draw eye. This is a very bad eye. This is, let's say, decent eye. Then this is the eye lens, right? Now what you have to do, you have to get your pencil and scale. Done. Where is the color? Wait. Okay, now it's visible, right? Now when the incident ray is coming from a near point, right, let's say this is the near point of the eye, but the near point has shifted away. In hypermetropia, near point shifts away. So the actual near point is here. This is the original near point. This is the new near point, right? We can call this as n dash, and this is simply n, right? Or you can call this n prime. Okay. Now originally the rays were coming like this, and the image was being formed behind the retina somewhere here, right? But we need to correct this. Okay. Now we have to draw the correction, right? So correction will be, we are using convex lens. Right? So what will happen? The rays will go here and they will diverge. They will little bit converge. They will converge a little bit and will actually make the image behind the new near point of the eye, and from that rays will go into the eye lens. And they will focus exactly on the retina. Done. This is the correction of hypermetropia. We are done with all our CBQs, right? We are done with all the CBQs. I hope you understood now. This session was highly based on how to solve CBQs. See, out of those 10 questions, how many did we read the actual passage? So if you read the first question, you will know that you have to read the passage or not. So jump directly to first question. Most probably you won't have to read the passage. Even if you have to read the passage, you know what it is about, what you have to see in the passage, the answer of which question you'll have to look in the passage, right? Just as we do in English. So that is it for this video. Do let me know all the answers I have asked you along with the slide number. Be very honest, right? So that is it for this video. All the CBQs, how to solve, how to read, how to do the questions, how to read the passage. That is it for this video. We'll meet in the next one. Till then, ta-ta, bye.